Hi everyone, I'm Cheryl. In this problem, we're going to be sketching the curve that's created by the vector value function, quantity minus t plus 1 times vector I, plus the quantity 4t plus 2 times your vector j, plus quantity 2t plus 3 times vector k. All right, now if you remember, if you plug values in for t, you're going to create some vectors. And the tips of those vectors will trace the curve that I'm looking for. So let's go ahead and find some values. So if I look at my components, I notice that the domain for t would be all real numbers. So I'm just going to try a few. Let's try -1, 0, 1, and 2. You may decide that you need more, or maybe this is overkill, but we'll start out with 4 samples and see what happens. Okay, so for the x component, if t is -1, I'm going to have negative a -1 plus 1. So that's going to give me 2. For the y component, this will be a -4 plus 2. So that's -2. And the z component will be a -2 plus 3, which is 1. So the vector that's created is 2i minus 2j plus k. All right, let's do this again, letting t equal 0. If t equals 0, my x component is going to be 1, my y component will be 2, and my z component will be 3, which gives me the vector I plus 2j plus 3k. If t equals 1, I'll have a 0 for my x component, a 6 for my y component, and a 5 for my z component, leading to the vector 6j plus 5k. And the last example I have is t equals 2. That will lead to a -1 for my x component, and add 10 for my y component, and 7 for my z component, which leads to the vector -I plus 10j plus 7k. Okay, now remember what I'm going to do to help me sketch this graph. I want to first of all sketch the vector 2i minus 2j plus k. But to be honest, really what I'm interested in is the terminal point. And so I'm just going to plot the point 2, -2, 1 on my three-dimensional coordinate system. All right, so on the x-axis, I'm going to be moving out 2 units. And then along the y-axis, I'll be moving in a negative direction 2 units. So I'm going to be moving 1, 2 units to the left. So I'm going to create a little parallelogram that looks like this. So I'm located right at this point. And now for my z component, I need to move up 1 unit. So I need to move up 1 unit from that. So here's 1 unit. So it looks like I'm right about here. Okay, so I've moved up 1. Okay, I'm going to highlight that because that's going to be the terminal point. I'm going to do a similar thing for the other points that I have. So my next vector is 1i, 2j, 3k. Again, the terminal point will be the point 1, 2, 3. So on the x-axis, I'll move out 1. Then I'll move on the y-axis 2 units. So again, I'm going to draw a little parallelogram that looks like that. That puts me right at this location. And on the z-axis, I have to move up 3 units, which is about that length. So starting from that point, that puts me right about here. And that's my terminal point. Okay. Let's try it again for t equals 1. For t equals 1, my vector is 6j plus 5k. So the x component is 0. So I'm really looking at that point 0, 6, 5 for my terminal point. So on the x-axis, I won't move at all. I'll move 6 units along the y-axis, and then I'll move up 5 units. And so that just takes me across and up 5 units. So that's going to put me right here. And again, I'm going to highlight that because it's my terminal point. Now remember, technically what I have is I have the vectors that are going to each of those points. I just haven't drawn the vectors in because that makes my graph look cluttered. Well, now that I have 3 of my terminal points, I think that's probably enough. I'm not going to use that 4th terminal point, although I could. What I can do, though, is connect all of those dots. To give me and I'm a little bit off, but as you can see, we're going to have a line that's going through 3-dimensional space. And that's my picture. Now there's one last thing we need to do, and that is mark the orientation down. Again, notice what's happening. As I take t from -1 through till 1, I'm going from this point to this one to this one. So I can tell that my orientation is going in that direction. I hope that was helpful. Thanks.